a reasonable, good grasp of what you're doing, this review will take an hour for most people. For some people that have to go back and relearn stuff, it's going to take 3 hours plus. Okay, so I'm going to be open for questions on this both Wednesday and Friday. I'm not going to teach anything. Friday is going to be open for questions, and that's it. I'm not going to teach anything new on Friday. Do you have a question?
I was saying for this final review, it's cumulative, right?
Yes. And there's nothing on the final that is not on the review. Okay? Nothing on the final that's not on the review. So again, that's going to take some time. So I notice only one person has done section 12.2. That person has 80%. And you need to get 12.2, 12.3 done. I mean, I'm going to give you enough information only to do 2 problems in 12.3 today. And then Wednesday I'll give you the rest, and there's only 3 problems after that. But you should be starting on this review. 12.1 should be finished, and you should be starting on this review immediately. Okay. I want to go to 12.2 and just do a few things, a few examples out of my lab. So this is kind of a repeat of what we did on Friday.
By any chance, can you do number 17 on 12.2?
Yeah, there's one I took out. Let's see. Not 7. Yeah, we'll get there. So let's look at, I'm going to look at number 1. I'm not going to spend the entire class on this, but we just want to do this to get our mind back into what's going on. It says, plot the points with polar coordinates 2 pi over 3 and -4, -pi. Then give 2 alternative sets of coordinate pairs for both points. So we have 2 pi over 3 and -4, -pi. This is a new pen. It should
Get
have a
going.
better one here, but we'll get that one working again. So remember, these are in polar form, and in polar form, this first coordinate is r, the radius, the distance from the origin, and the second coordinate is theta, the angle rotating counterclockwise from the positive x-axis. All right? So you actually want to start by looking at that angle. Pi over 3 is like 60 degrees. So rotate up here 60. And then our radius is 2. That's the distance from the origin. So we're just going to be approximate here. It's going to be somewhere out here. 2 pi over 3. And that's it. This one, -4, -pi. Again, let's look at the angle first. Pi is like 180 degrees. So -180, instead of rotating counterclockwise, the negative makes us rotate clockwise over to here. The radius is -4, that's the distance from the origin, so be somewhere out there. Okay, so let's find those results in Pearson. Got the first quadrant, and we have the negative x-axis. Looks like B to me. You agree? Edit? It's incorrect. Uh-oh.
Yeah, that negative. They always want us to flip that
I'm
sign.
sorry. I made a mistake. Okay, Ernie? That 4 is negative.
Why though?
Okay. Negative pi, rotate over here to the 180 degrees this direction. Now negative 4 flips us another 180 back over here. It's going to be over here somewhere. You guys all right with that? Okay. I need to be more careful up here. So that looks like C. Do you agree with that?
Mm-hmm.
C? All right, so now we need to give two alternative sets of coordinates for 2 pi over 3. Well, 2 pi over 3, that's this point up here in quadrant 1. Remember that. Pi over 3, like 60 degrees up here in quadrant 1. So, 2 pi over 3, is that in quadrant 1? No, 2 pi over 3 is like 120 degrees. That's in quadrant 2, so it's not going to be A. Negative 2 pi over 3, where's that? Yes, you're right. So, negative 2 pi over 3 would rotate us down here, like negative 120 degrees. And then the negative radius would flip us back up here, right? That puts us in quadrant 1. Is that a possibility?
Yeah.
Yes, that is a match for that right there. What about this one? What's 7 pi over 3?
Add 2 pi.
All the way around is 2 pi, correct? 7 divided by 2, I'm sorry, 7 divided by 3. 7 divided by 3 is 2 with a remainder of 1, right? So that's like 2 pi plus another pi over 3. 7 divided by 3 is 2, remainder 1. So that's 2 pi, that's the 2. And the remainder 1 is another pi over 3. So that puts us up here, that's good. And we got a positive 2, I think that works, doesn't it? You guys agree? Yeah. Now we need an alternative set for negative 4, negative pi. So let's remember, negative 4, negative pi is over here on the positive x-axis, 4 away from the origin. A, 3 pi. That takes us all the way around and then another half. And then they have a positive 4. That's not going to do it, is it? That'll put us on the negative x-axis. The 3 pi.
But couldn't it be because both of them are negative, so that's the first one is.
I'm looking at this one right here. This is over here. Now, we got to find which one of these is a match for that. This one, 4, 3 pi. There's 1 pi of rotation, 2 pi of rotation, 3 pi of rotation. And then 4 puts us out here. That's not a match for that. That make sense? So it cannot be A. B, negative 4, 0. 0 degrees of rotation is here. Negative 4 flips it over there. That's not a match. C, 4, 0. Again, 0 degrees of rotation or 0 radians of rotation puts us here. And 4 puts us there. So that does match. That matches this one. The first one does. This is good. what about this? Well, pi puts us over here, -4 puts us back over there. That's good as well. C, they both match. It's gonna be C. Let's just look at D, see what's wrong with it. 4 -pi. -pi puts us over here. 4 is distance from the origin. It leaves us out here. It doesn't match that, does it? So D is not going to work. Are you guys able to trace that out? Now remember the set, you want to start kind of backwards what we're used to with X and Y. In this case, we want to begin with the second coordinate, which is the angle, and figure out where that rotation puts us. Then do the radius, the distance from the origin. And if it's negative, you got to flip it 180 degrees to the other side. Okay? All right, so that's how number 1 works.